Yes, sir.
So you should know these things, because all the things I think if I am not wrong, I have discussed it three times in your physical classroom in Indore itself.
Yes, sir. Yes, sir.
Okay. चलिए आपका क्या ये चैप्टर खत्म हो गया, एटम्स एंड मॉलिक्यूल्स? ये चैप्टर का खत्म हो गया आप लोग को?
सर मोल कॉन्सेप्ट नहीं हुआ, मोल कॉन्सेप्ट
नहीं, आई एम जस्ट आस्किंग टू इंदौर स्टूडेंट्स, बाकी तो पता है मुझे। इंदौर Rajab, atoms
Yes,
and
sir.
atoms are completed or not?
Yes, sir. Yes, sir. Yes, sir.
You should know, na? You should know about these things. I think you know already.
Yes, sir. Yes, sir.
So it's very good. चलिए आपको how many of the students know about radicals? Radical के बारे में किसको पता है? Munshi Tawqir. Okay, Munshi Tawqir, can you say what is the formula of bicarbonate? Yes.
Sorry, sir.
Bicarbonate. What is the formula of bicarbonate?
Sir, HCO3.
Then
HCO3, sir, I think it will be plus.
no, minus. Okay, see, this is a very good question. One of the students was asking, so how to handle the formula of this kind of compound? Like, okay, just let me share the board first. Yes.
Sir, how can I determine that which one is positive and which one is negative charge?
Very good. So before that, you should know, about this is another fundamental concept that you should know. Just let me go through with this, because this was the chapter as discussed in the structure of atom. This is the next chapter, but I think this is a preliminary concept that we should know always. Like that, we are writing carbon. Okay. Before that carbon, we are starting with the lithium. So what will be the electronic configuration over here?
1.
That means K equal to 2 and N equal to 1. So now the question is, the valency of the lithium will be 1. See, lithium is a metal or non-metal? Lithium is the metal, lighter metal. Is it not? Lithium is metal. Why? This lithium, or you can say about sodium and potassium also, same rules with the sodium. Sodium is 11. So this can remove the electron. The class type of class. So the electronic configuration will be 8 and 1.
Yes, sir.
So now tell me, this sodium want to lose electron or the sodium want to gain electron?
Lose.
Lose electron. Sir, lose electron.
Arifur, why want to lose electron? क्यों electron छोड़ना चाहते हैं?
Sir, because it is difficult for an element to grabbing 7 electrons. So it is more easier than to losing 1 electron.
Very good. उमेर अब्बासी, आप बोल सकते हैं मोहम्मद उमेर अब्बासी.
Yes, sir.
ये क्यों सोडियम क्यों ऐसा, मतलब एक इलेक्ट्रॉन क्यों छोड़ेगा?
So because 8 electrons is already here.
तो एक इलेक्ट्रॉन छोड़ने से मतलब फायदा क्या है उसको? Anyone else in the class?
They can
मासूम से
fulfill the octet state.
They can get the nearest noble gas.
Very good. क्योंकि नियरेस्ट नोबेल गैस जो है इसका जो है इलेक्ट्रॉनिक कॉन्फ़िगरेशन ये गेन करना चाहता है, इसी वजह से ऐसा होता है ना? गुड. सो नाउ इफ द सोडियम wants to lose 1 electron, so what will happen? What the changes in charge? See,
positive.
Yeah, this is 0. If you are not writing anything, that means it's 0. So it's losing electron, that means it's losing the negative charge. So it will be definitely
Positive.
Definitely it will get positive. Are you getting my point?
Yes,
Yes.
sir.
Yes, sir.
So by this way, actually these things happen. So it's my suggestion to all the students, before doing these things, you should know about electronic configuration. So simply you should make a chart like this. This is the serial number, and then the name of the element, then the symbol, then electronic configuration,
Yes, sir.
and then valency.
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 So atomic number.
Yes. Then charge, and then nature of the nature. Nature means whether it's metallic or non-metallic. Okay. Like this, I'm just giving one example of this. You should continue at your home. The first one, sorry, one more thing I have missed here. It has to be included. That is the atomic number. Atomic number. Otherwise, you cannot do it. Let's say I'm writing 1, 2, 3, 4, 5, 6. So I'm taking carbon here. So how many electrons are present in carbon?
6.
6.
The symbol will be C.
C.
And the electronic configuration will be
2 and 4.
2.
4.
Balance is 4.
What will be the valency over there?
4.
Sir,
It will be 4. And the charge will be 4 plus.
Positive.
And nature?
Metal.
Non-metal. Non-metal. Or non-metallic, you can say. By this way, please continue at your home up to 20. Up to 20.
How can it be non-metal? Means
Okay, sir.
Very good. See, that's why I have chosen carbon. So until unless I am taking carbon, the next atom will be fluorine. Is it not? Sorry. The next atom will be
helium.
nitrogen.
Nitrogen.
So it's a 7, and we are writing is nitrogen, and 2 and 5. So for nitrogen, it's not possible to lose the 5 electrons. Although nitrogen has 2 valencies. Nitrogen का 2 valency होता है, 3 और 5. Because we are taking it valency 3 here. So the charge will be 3
minus.
And it will be metallic.
Metallic.
Metallic, are you sure?
No, sir, non-metal.
Yes, it's a non-metal.
awesome means when it is gaining, it will be non-metal.
Yes, absolutely.
Sir,
right.
but we can say here, means in the carbon, there are 4, in the last cell there is 4. So it can also lose 4, means gain 4 or also lose 4.
Yes, in the higher grade, actually.
So why it is not neutral?
Yeah, it's not neutral because it's a 4. There is a tendency, जब जिसका पास ईमान थोड़ा सा कम होता है, कभी बीजेपी में जाता है, कभी तृणमूल में जाता है ना? कभी इधर जाता है, कभी उधर जाता है. तो कार्बन का भी ऐसा बात है कि कार्बन भी कभी-कभी ये 4 माइनस भी होता है. आप ऊंचा क्लास में जाके इसको पता लगेगा. जैसे नाइट्रोजन का वैलेंसी 5 भी होता है. That's why we can write NCl3 and LCl5. और नाइट्रोजन का नीचे रहता है फॉस्फोरस. नाइट्रोजन का कितना होता है इलेक्ट्रॉन? How many electrons are present? 7. In phosphorus, 15. So in case of phosphorus also, you can write PCl3 and PCl5. There are 2 valencies of this group, that is the nitrogen phosphorus, 3 and 5. And in case of carbon also, carbon can form carbocation and it's also from carbon. Sorry. ठीक है, तो नाउ इन दिस वे यू नीड टू कंप्लीट दिस चार्ट। आपको 20 तक ये चार्ट पता लग जाएगा, तब इसको पता लगेगा कि मेटल कौन है, नॉन मेटल कौन है ना। सो चलिए, तो मैं अभी इसमें वापस आता हूं कि इसमें कैसे क्या हो रहा है। जैसे कि बोरन का होता है ना, बोरन, हाउ मेनी इलेक्ट्रॉन्स आर प्रेजेंट इन बोरन? हाउ मेनी इलेक्ट्रॉन्स आर प्रेजेंट इन
4.
Sir, 4.
4? That means 2 and 2.
2, 2.
So what will boron do?
Sir, valency will be 2.
You are actually you are telling wrong. See,
Sir, boron has
Sir,
5.
5.
Boron has 5.
so just let me do something to remember these things in a short way, short manner. In Bengali में, बंगाली में बताऊंगा, लेकिन इंदौर वाले थोड़ा सा डिस्टर्ब होंगे, लेकिन फिर भी आपको पता लग जाएगा the whole thing. So ये पढ़ाया था 2 दिन आगे, नारायण देवनाथ. Do you know Narayan Devnath?
No, sir.
Who is the famous writer of Monte and Fonte? He's a cartoon.
Bengali famous comic writer. He has
Yes.
expired yesterday.
Yes, Nonte Fonte and Batul the Great. Okay, so we say that high means hydrogen and helium, and we say Laju Boga. তারপর আমরা বলি বন্ধু কেমন বন্ধু নন্টে ও ফন্টে নিয়ে। হাই রাজু বোকা, বন্ধু কেমন, নন্টে ও ফন্টে নিয়ে। Now we are writing it hydrogen and helium. Now Laju Boka, lithium. Boka means beryllium. That means boron. কেমন বন্ধু, কার্বন, ফন্টে, নাইট্রোজেন, chlorine, neon. Okay, so now we can write their electrons, number of electrons: 1, 2, 3, 4, 5, 6, 7, 8,
9, 10.
10. So now in this way, lithium, after the lithium there will be an electron, there is a sodium, and there will be potassium. In case of this, it will be magnesium and calcium. Here it will be aluminium. And carbon, there will be silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, and neon, argon. So right here, now we can write also the electrons there. It will be 8. No, it will be 3 plus 8. That means 11. 11 plus 8, 19. 4 plus 8, 12. 12 plus 8, 20. 5 plus 8, 13. Or in the other way, 13, 14, 15, 16, 17.
2 plus 2 is 5.
Are you getting it?
Yes, sir.
Yes, sir.
Yes, sir.
Is there any problem?
Yes, sir.
No, sir.
No, sir.
It's a very, very, very important for all the students for the grade 10
Yes, sir.
also. Because what I have written here actually a part of periodic table.
Sir, can you explain again?
In the periodic table, there are 7 periods and 18 groups. 7 periods and
Yes.
18 groups are present in a periodic table. And there is a group number 1, a group number 2, and group number 5, 6. Sorry, group number, how many is group number 13? Group number 14, group number 15, 16, 17, 18.
18.
Right? All the things. Okay. I will just share you the periodic table so that you can understand in a later stage you can understand. Okay, this is the group. I just written with a group. That's why the difference between this compound, this element is 8. 3 plus 8.
Can you explain this again?
Yes. First of all, I just explained that the way, how can you remember that? The numeric, someone can also say that H, L, B, B, C, N, O, F, N. In this way also you can remember. But I say, it's a Narayan Devnath. Hi, Raju Boka, Bondhu Camon, Nonteo Fonte Nie. By this way, hi means hydrogen, helium. Raju Boka means lithium, beryllium. Bondhu Camon, boron, carbon. Nonteo Fonte Nie, nitrogen, oxygen, fluorine, and neon. Okay. So now, can you see this? The electronic numbers, the number of electrons are present. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And then you can see 11, 12, 13, 14, 15, 16, 17, 18. And last, Arif Ahmed, what are you saying? Okay. So by this way, we can write in these things. So in periodic table, there are 7 periods and 18 groups. Okay. How many periods are there?
18 pairs.
Yes.
Sir, 18.
18. 18 groups. 18 groups. So 18 groups are there in a periodic table. So now in this way, actually we can say about the periodic table. Say, so I have what I have written here, group number 1, group number 2, and the last 2 groups I have written on your screen. Okay, so that you understand it quite easily. In the later in the next class, you will be able to know about these things in deeper understanding. But you should know about up to 1 to 20. Otherwise, it will be tough for us to to understand these things. So till that, before that, we should know who is saying. So I will be just able to I need to mute all of you if you are saying this manner. Okay. So in periodic table, the modern periodic table is based on what? The modern periodic table is actually based on the electronic configuration. Okay.
Whole lot of niggas.
So can you see this? Is my screen visible to all?
Yeah.
Yes, sir.
Yes, sir.
I just wanted to share something else. Just let me do this. Yeah, now you can see this. So group number 1, group number 2, group number 13, 14, 15, 16, 17, 18.
Shut the fuck up, nigger.
So these Arif Ahmed, there is a constant sound coming from your vent. Please control yourself, otherwise I will be bound to remove you. Because for class 9 and 10 students, I don't want to be mute all the students because you need interactions. Okay. So now are you getting it? Can you see this? So you can take a screenshot of it. Till 1 to 20, you should remember all these things. So after this group number 14 and group number, from this group number 14, all the elements are non-metals. And group number 1, group number 2, and group number 13, all the elements are metals. So this is
Sir, what is the use of this group? Means for what?
Yes. Actually, this group has been made. So lots of elements in the world. Okay, so we know the properties are near about 118 elements. 118, 119 एलिमेंट के बारे में आपको पता है. तो साइंटिस्ट ने क्या किया? जिसका सिमिलरिटीज है प्रॉपर्टीज का, those elements have the similar properties, उसको एक जगह में रख दिया. It's like a book shelf. So if you are keeping all the horror book in a shelf, in a column, and you are keeping all the story books in a column, if you are keeping all the science books in a column, arts book in a column, it's like that. आपके पास एक book shelf है, and you have got 18 columns. So in 18 columns, you are keeping 18 kind of books. Or you can compare it to an almirah. पहला ग्रुप में हम लोग बच्चे का रख लिया, है ना, बच्चे के शर्ट को रख लिया, फिर बच्चे को पैंट का कपड़ा रख लिया. ऐसे हम लोग सारे ग्रुप को इसको कंप्लीट करते हैं. So you can see that all this similar kind of thing you can see. This is the complete periodic table. This is a complete picture of a modern periodic table. So we can say long periodic table.
Sir, can you please repeat again?
Yes.
So
It will
what
be
is
the-
that means the violet color 1, 2, 3, 4, 5, 6, 7 and the green color?
Yes, you can give it different colors. I will explain it in the class 10. See, I'm just giving an example. Group 1, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These all are metals, strong metals. So basically we call it alkaline metals. Why call it alkaline metals? Sodium hydroxide, potassium hydroxide, lithium hydroxide, we can take. That's why they have called that alkaline metal. That's why all this metal
They
actually
can
form.
react with water.
This I have to remove Arif Ahmed. There is no, I'm sorry to do that. Otherwise, this one student is being disturbed constantly. I think he has left. Need to just remove. It's a waiting room. Good. So now, and this next group was the next group is group number 2. These are called alkaline earth metals. Alkaline, all the alkaline earth metals we have kept here. Beryllium, magnesium, these are also strong metal, but not strong as the group 1 element. Okay. And then if we can move to group number 13, see boron, aluminium, gallium, indium, thallium. Group number 14, the similar kind of properties are here. Like in fluorine, chlorine, bromine, iodine, we call it halogens. Because इसका engineer ये produce कर सकता है क्या? Salt produce करता है, like NaCl, NaF, NaBr. It can produce salts. Halogen means sea salts. Okay, and then chalcogen, oxygen, sulfur, all are called chalcogen. Nitrogen, phosphorus, arsenic, antimony, bismuth, all are called pnictogen. And you know the similarity between arsenic, antimony, bismuth. They do not have, neither have properties of metals and nor have properties of, or both the properties they actually having of the metals and non-metals. That's what we are keeping here. Okay. Helium, neon, argon, krypton, Zn, radon, all we know these are noble gases or inert gases because they do not want to share electron with anyone. That's why they are termed as noble gases or inert gases. So we will discuss it in more more in details in class 10. But you should know till 20. So arrangement, whatever I have written there, the arrangement is like the same what I have written in the board. Are you getting it?
Yes, sir.
So can you explain again group number 2?
Yeah, group number 2 are alkaline earth metals. So this is also strong metal, but not such as group number 1, because in the last cell in group 1 you can see the number of electron presence is 1, 2, 1, 2H1, 2H81. In all the cases, in the last cell the number of electron is 1. But in case of group number 2, you can see the electrons present. How many electrons are present? It's 2. So that's why those who are having 1 electron, उसके लिए ये electron एक electron छोड़ना बहुत आसान है. So he can easily lose 1 electron. But in case of 2, it require a little bit of more energy than group 1. So that's why they are also strong metals, but not as group 1. They also form basic compounds like magnesium hydroxide, calcium hydroxide, beryllium hydroxide. All are strong bases.
Uranium.
Uranium is a radioactive element. Lanthanum, actinium, you can see the star elements are there. So the actually lanthanum, actinium is a radioactive element. The group 7, they are a radioactive element, francium, radium, and the lanthanum from group number 57 up to 71. There we called, I will just rare elements. I will explain it later, or you will come to know in class 10. Okay, because we are not shifting our focus from atoms and molecules to periodic table. So for now, I think for the time being is okay for you to understand. Okay, so just I am moving now. So this way, this is also very important in another sense. is that just I have reminded you about the chart. So can you see this? All the elements here are present: hydrogen, lithium, sodium. They have the valency of 1 and they have the charge of +1. And in this case also, beryllium, magnesium, calcium, strontium, all the elements have the valency of 2 and charge is +2. Okay, in this way, so we have kept all, they have kept all the elements in a single column, those who are having same charges and same valency. In boron aluminium, all are having how many valencies are there? 3. Why it is 3? Because they want to lose 3 electrons here. In case of carbon, so actually they can have 14. You can see 13, 14. So what is the 14 and 13? So in the last lecture, I will explain it in the class 10 why they have written here 13, 14, 15, 16, 17, 18. But the idea is that in the same way, the nitrogen, phosphorus, arsenic, antimony, bismuth, all are having valencies of 3. Okay? Are you
Yes,
getting
sir.
it? Now,
Yes,
so
sir.
now we are moving to the, yeah. So as far as we know, if the element loses electron, then it's metal. And if gains, then it is a non-metal. Then what basis we divide metal as? Okay, we'll explain it. So now for the classes again, we are drifting forward, whatever the competencies we are having. So let me focus on those things. There's a very good question someone has asked me, that how we will manage like ammonium sulfate.
Sir.
That is multiple elements when we are writing the formula. So in that case, what do you need to do? Just you need to know about radicals. Faransik, unmute yourself.
So the 118th element, so it should be a noble gas. So why it is UUO?
It's an unknown element. That's to be revealed all the properties. The research is going on. Okay.
Okay, sir.
Sir,
Yes.
sir, I'm asking that I have seen many periodic tables. 118 number is OG and in some of this UUO. What is the meaning of that, sir?
Actually, what I have said is that it's yet to reveal the properties of that element. The research is going on. So that's why they are keeping it this way. They have the name, but the scientists are yet to get all the detailed property about it. So that's why they have kept it this way. So I'll just explain it when it will come to that topic. So right now, let me focus on the radicals. So
What is radical, sir?
Yeah, now that is the thing that's coming here. What is radical? Radicals means the group of elements, group of atoms are with the charge. Group of atoms with the charge are called radicals. Just I will quickly go through the video and I will also explain it.
Whom they are comfortable with and they like. And now that group together hangs out together, goes to places and so on. Similarly, in chemistry, some atoms act in a group. They form a group. That group can have same or different atoms, that is, atoms of same or different elements, and they are combined chemically. And now that group of atoms act as a single unit with a positive or negative charge. Such a group of atoms is known as radical. So radical is a group of atoms of same or different elements combined chemically that act.
So you can see this, what is radical? Radical is a group of atoms that can combine chemically. Okay, so that can be with a single unit with a positive or negative charge. So just I'm quickly moving through it. So now compound. A compound is a group of atoms of the same of the element combined chemically and behaved as a single unit. So now can you see this, some of the example?
Then in radicals, you saw that there was a positive or negative charge on the radical. So the difference between radicals and compounds is that radicals, they have a positive or negative charge. They are a group of atoms of same or different elements combined chemically, which act as a single unit and they have a positive or negative charge. But compounds, they are the group of atoms which may be of same or different elements. They are also combined chemically to act as a single unit, but they are neutral in character. So radicals, they have an overall positive or negative charge, and compounds are neutral. So let's see some radicals. Ammonium. Ammonium radical is NH4 plus, and hydroxide radical is OH minus. Now this plus charge is for the overall radical. So this is NH4, and this plus charge is for both nitrogen and hydrogen. So this is how this is represented. Okay, how do we get this positive charge here? The valency of nitrogen is -3, and the valency of each hydrogen atom is +1. So we have 4 hydrogen atoms. So we get -3 plus 4, which is equal to +1. And this +1, when we do not write a 1 here, this means +1. So this +1 is the overall charge for this ammonium radical. So this can be represented as NH4 plus, or at times, to avoid discrepancy, this can also be represented as NH4 plus. But most of the time you will see it represented like this. So this plus charge shows that it's for the entire ammonium radical. Similarly, when you have OH minus, so the valency of oxygen is -2, valency of hydrogen is +1. So the overall charge becomes -1. So this hydroxide radical has overall -1 charge. So this is a positive radical, ammonium radical, and hydroxide radical is a negative radical. So radicals can be both positive or negative. So these are some other radicals.
So till now, is it okay? You need to write also. Okay. Otherwise, how we get charges? How radical form? This is the group of elements that is coming together to form a radical.
So how you get the charge?
Yeah, that is the calculation. No? That is the calculation we have done it. So see the sulfur, we know the charge of sulfur, or also we know the charge of oxygen. So now we have to calculate the total charge of the element. So by which we'll came to know about these things.
So you see sulfite radical is SO3 2 minus, and sulfate is SO4 2 minus. So now there's another system of naming them. When there are lesser number of oxygen atoms, they are given the suffix "ite". When there are greater number of oxygen atoms, it's given the suffix "ate". If you'll observe these two radicals, you see that this radical has lesser number of oxygen atoms, this has greater number of oxygen atoms, and this is the only difference between these two atoms. So now the first radical is nitrite, and the one with greater number of oxygen atoms has the suffix "ate". So this is nitrate. The presence of "ite" and "ate" shows the presence of oxygen in the radical. So anytime if you encounter a radical which has "ite" or "ate" in the suffix, that always means that there is the presence of oxygen in the radical. Out of PO3 3 minus and PO4 3 minus, the phosphite radical is, so which of the two do you think is the phosphite radical? We know that the suffix "ite" is given to the radical with lesser number of oxygen atoms, and out of these two, this radical has lesser number of oxygen atoms. So this is the phosphite radical. So what should be the name of this radical? This has greater number of oxygen atoms, and therefore this should be phosphate radical. Let's look at some other radicals. We have carbonate radical, which is CO3 2 minus, and bicarbonate radical, which is HCO3 minus. Now whenever you see a bi added before the name of a radical, that always shows the presence of a hydrogen atom before the radical. So in this case, you see sulfate radical, which is SO4 2 minus, and if we have a bisulfate radical, that means there is hydrogen present before SO4. So it becomes HSO4 minus. In this case, the charges are not the same, but the presence of bi before the radical name always shows the presence of hydrogen atom. And since you see 8 present in all the radical names, So this shows the presence of oxygen atoms in the radical. So these are some of the common negative radicals. Most of the radicals that you will see are negative radicals. Only a few radicals like ammonium, they are the positive radicals. Rest all radicals that you will see and use, they are negative radicals. So how do we name the compounds that have radicals? Alright, so these are certain compounds. They have radicals in them. So the first compound is sodium and the radical nitrate. So how do we name it? It's named as sodium nitrate. We always name the positive part first. So we have positive and negative. We know that radicals, most of the time radicals are negative. So the radicals are named.
This concept is here is about the metals and non-metals. See, it's not about metals and non-metals, right? And we are writing the formula of carbon dioxide. So both are non-metals, is it not? So it's not about metals and non-metals. It's more about the electronegativity and electropositivity. So the elements which are more electropositive, that has to be, that has to become first, and the latter part will be the negative part. So in some of the books you can see that the metals, it's not about metals. In some of the elements you cannot see the metals, cannot able to find the metals. So in that case, both are non-metals. We need to know about this electropositivity and electronegativity. Okay.
Hello,
After
sir.
the positive part of
Yes.
the...
Sir, may I leave because it has very less charge in my phone.
What's your name?
Sir, MD Wasim Sheikh.
Okay.
compound.
Thank you, sir.
So here sodium, it's positive since it's a metal. Nitrate.
Okay, so let me share you the screen. So just going this the board one. Okay. So is my screen visible to all?
Yes, sir.
Yes, sir.
So now what you came to know about from this video, and whatever is given in your if you are using the book page number 145 in this chart, that is written here valency of ions, right?
Yes, sir.
Okay. So what is the valency of iron? So basically the valency of an ion is equal to the charge on the ion. First of all, if you can take the monovalent, that means the valency will be 1. So monovalent cations. So we have already know the term mono. Mono means 1.
1.
So what will be
Yes,
that? Hydrogen. So we have hydrogen plus, that is H plus.
Sir, if the charge is less, then it will be cation.
Yes, the charge is plus, it will be cations. Okay, before that you should know about the term cations and anions also. Right, very good question. So these are ions are basically divided in 2 parts. One is cation and another is anion. So the negatively charged ion are called anion. Positively charged ions are called cation. Okay. So when a neutral atom is tendency to lose electron, so basically they turn into cations, and the neutral atom is gaining electron, so they are basically converting themselves an anion. Okay, good.
Okay, sir.
So these are the example of H plus, Li plus, and some of the examples of Na plus. Now all the things, whatever you have written in the metal, if you can see the metal part, whatever I have written in the group 1. So basically I am writing about the group 1 in periodic table. H plus, Li plus, Na plus, K plus, is it not? And there are some radicals also like ammonia, NH4 plus. Most of the radicals are negative. Some of the radicals are positive. Among them, ammonium is one of them. Okay. Then Ag plus, silver ion. You can say copper ion is there also, Cu plus, and also Hg plus. Okay. So now we are moving to, sorry. Yeah. Now we are moving to divalent. So di means
Double.
2. Di means 2. So what will be the example of divalent cations? Can anyone say me?
Boron.
No, it's not boron. Is there anything else?
Sir, oxygen.
Yes, oxygen you can see. See, divalent cations. I'm not saying by anions. Oxygen is anion. Is it not?
Sir, when an atom loses or gains to
The calcium.
protons.
The magnesium.
Two elements, can you remember? We call the group 2 elements, whatever written. Beryllium, magnesium. Can you remember that? So beryllium 2 plus is there. Magnesium 2 plus is there. Is it not?
Yes.
And also it's like Ca2 plus, Ba2 plus, Cu2 plus. Okay.
So what is Ba2?
Barium. Zinc is another important element. Zinc 2 plus. Iron has 2 valency. So one the valency which is the least valency is called. Can you say what is the name of this compound? If I can write Fe2 plus and Fe3 plus, what is the name
Sir,
of
variable valency.
Yeah, what is the name of Fe2 plus and what is the name of Fe3 plus?
Sir, ferrous and ferric.
Very good. So what is the rule there? What is the thumb rule there? Can you say me what is the rule there? So the elements which are having lower valency are called As, and higher valency we call it Ik. বাংলাতে বলে বড় আশা করে এসেছি, মানে আশা আছে কি আমার আরো চাই, that means Fe2 plus. আর অধিক বেশি অধিক, that means Ik. As, Ik. As means
Asha.
that means lower valency, and Ik means higher valency. So these are the very fundamental things you should know, and believe me, till graduation the students are really struggle to remember potassium ferricyanide, ferrocyanide, ferrous ion or ferric, whether with the name as ferric chloride or ferric chloride, ferrous chloride. These are very, some of the things that is confused us, like cupric chloride or it will be cuprous chloride. So the Cu plus is there, that will be cuprous chloride. In case of Cu2 plus, that will be cupric chloride. Are you getting my point? Like Cu plus and Cu2 plus. So these are the things that you should know apart from divalent cations. So how to name these things? This is also important for us to know this. Okay. So basically we have known about divalent cations also. So now let me put another things, trivalent cations. So okay. So can you see these trivalent cations? What will be the example of trivalent cations? Group number 13, is it not? Boron, aluminium, these are the compounds. That means
Yes.
Al3 plus and
phosphorus.
Fe3 plus, is it not? So trivalent cations means having the positive charge of 3. So now I am moving to 9. That is monovalent anions. So what will be the example of monovalent anions? That's a plain T, is it not? H minus, then F minus. Can you remember the chart? Fluorine, chlorine, bromine, iodine, astatine. So all are consisting of example of
A same element can be cation and anion too.
there is only 1% better, and we call it Dushtu mode, naughty element. It's hydrogen. Hydrogen can be H plus and hydrogen can be H minus. How? See, the role of hydrogen here. Li plus, then it will be H minus, is it not? In the same case, you can say CH4, or in the another HCl. In HCl, you can see it is H plus Cl minus. But in case of lithium hydride, you will see the different cases. Okay, when you will be in degree course, if you are reading chemistry, you are learning chemistry, you'll also know about carboanions. You have heard about carbocations, but the existence of carboanions are also there. Okay, good. So these are the things: H minus, F minus, Cl minus, Br minus. Now we are talking about the more than 2 elements when it's compiling. So in F minus, it is Id minus 6, 7, 8. It may be more than that. There's plenty of things. Na2 minus, okay, NO3 minus, and HCO3 minus. Also, you can write OH minus. So how can it be OH minus? As I'm giving an example. That means the total calculation of charge. O means minus 2. Hydrogen means plus 1. What will be the total charge of OH minus? It will be minus 1. Are you getting it?
Yeah, sir. We have to know the charge first, then we can calculate it.
Then automatically you can calculate. In case of hydrogen also, you can see that automatically you can know all the things here from here, and then automatically calculate the charges of that anions. Okay, good. So now we are moving to our next, that is divalent anions. So divalent anions means anions having valency of 2 minus. So that is oxide H2 minus, sulfate SO4 2 minus, and carbonate CO3 2 minus. So now we are moving to trivalent. So that's the example of trivalent anions. Is N3 minus, P3 minus, and PO4 3 minus. This is a very example, this is very important thing. What you can see is that because these are the compounds which really, when you are writing a formula, so that will create some kind of confusions like this phosphate and this thing. And some of the metals there, I have already mentioned it, they have 2 valencies. Like, more than 1 valency, okay, or 2 valencies. So what are this?
A metal can have 2 valencies.
Cu plus, Cu2 plus, Fe2 plus, Fe3 plus, Hg plus, and Hg2 plus. So can you see, I have consciously written in this way. So I could have written here Cu2 plus, but I have written it Cu double plus. Both are correct. Okay. So these are the things also we need to keep in our mind. Otherwise, it will be a wrong thing. It's the mercurous, and what will be mercury. Can you say what is the name of Hg plus and what is the name of Hg2 plus? What is the name of Hg plus?
Sir, mercury.
No, mercurous. Because it's a lower valence. It's a lower valence.
Yes, sir, mercurous.
Yeah, it will be mercurous. And Hg2 plus will be
Mercuric.
So So you should know about these things also. Otherwise, it will be a wrong thing to be understand. Now, just I'm coming to the last part because it's more than 1 hour and 10 minutes almost is over. So now the first question what I have received from you. So I'm just getting back on that questions. So when you are writing the formula of aluminium sulfate, so symbol of Al and SO3. So Al and SO4. Okay. So Al has a valency of 3 plus and SO4 has a valency of 2 minus. So now you have to go through crisscross method. So what will be the final formula? Al2 SO4 O3. Are you getting it?
Yes, sir.
Yes, sir.
And the name will be aluminium sulfate. Very important thing, yum, yum. What is it? Yum. Yum means the anions having positive charges are called yum. It's called ammonium, aluminium. Is it
Sir?
not? Yes.
Sir, I'm asking that why we have not written Al2 minus and why have written Al2 plus? Because there is 2 minus.
So this is a crisscross method. The idea or the rule of writing a formula, so you have to go back. Like aluminium has a valency of 2. Sorry. 2. And oxygen has a valency of 3. So what do we write? Al2O3.
Al2O3.
So in this way, in both this way, I will just written here. Also, someone could have write here O2 minus and N plus 3. Doesn't matter. Because when you are writing a formula, you should not write the charges over there. Are you getting it now? Masum Sheikh?
Yes, sir.
Yes, sir.
Okay, good. So these are the things that you should know. So I will just give you some of the practices that you will practice in your home and let me know that whatever the your learning are completed or there. Is it completed now?
So again, can I have just left the meeting? Please again said it.
Sorry, I'm just not getting you.
So I just got left the meeting. So can